Hello everyone, welcome to my lecture series of data structures and algorithm. I hope you have gone through the previous lecture in which I have explained push operation, or you can say insertion in stack. So now in today's lecture we will be understanding pop operation, that is also called as deletion in stack. So before understanding the algorithm of pop operation, we have to understand few cases. It will make you understand the algorithm better. So the first case here is when your stack is empty and we further try to delete any element from this, that condition will be underflow, right? Again, I'm taking the same example. So in that case, if I take the bucket example, your bucket is empty, right? And let's say if your bucket have some water, so you want to take 1 mug of water, then it is possible if the water is there in the bucket. But if your bucket is empty and you're trying to take 1 mug of water, is it possible? Just think it practically. So it is not possible, right? So if your stack is empty, right? So the data structure is empty. There is no element present in the stack. So how can you delete the element? So we will simply check the condition and we will say that that is underflow condition. And when that condition will arise, when your top will be pointing to -1. In that case, we will simply print this message and we are not going to further do anything, right? Now in case 2, when your stack is empty, that is what I have discussed now, your top will be pointing to -1. Now let's understand it with the help of example. Now we have a stack whose size is 4, and so the first location will be 0 and the last location will be 4 minus 1, that is 3, right? Now we have taken an example where the stack is full. So your top will be pointing to the last location, that is the third location, and here the data is being placed. Now when I have to delete this particular data, so for that what happens? First we will delete the data. So when there will be no data available, then only your top pointer will decrement. This is a very important point which is being committed wrong by students. So when they are writing the algorithm, they just don't take care of this point, that in stack insertion, first you have to increment the top and then you have to insert the data into that incremented top value. But in case of deletion, until unless the data is not deleted, how will it point to the next value, right? This one. So first the data has to be deleted and then your top will be decremented by 1, right? So now when I delete this particular data, what will happen? First it will be deleted and then your top will be 3 minus 1, that is 2. Now let's understand it. So we have seen that when I have deleted the data, now your top is pointing to second location, right? Now again I have to delete this data also. So in that case, again your data will be first deleted, and once it is deleted, so this top cannot point to this location because it always points to the last data location. So as we know that there is no data available here once it is deleted, so your top it will be decremented by 1. So 2 minus 1, that is 1, and now I'm deleting this data. So now you can see that data has been deleted. First the data has been deleted and then your top value will get decremented. Now again I want to delete this data as well. So in that case, again first your data will be deleted and then top will be top minus 1, that is 1 minus 1, 0, right? Now there is only one element present in the stack, that is pointing to 0th location. Again we have to first delete the data once it is being decremented. So you can understand that 0 minus 1 is equal to -1. And when your top is -1, in that case your stack is empty, and you can also see that all these cells are now empty, right? Now if you try to delete something out of it, which message it is going to display? What is the condition that we have discussed in the previous slide? That is the condition of underflow. So when this stack is empty and you're further trying to delete something out of it, that condition is called as underflow. And in case of insertion, when your stack is full and you're further trying to insert any element into that case is called as overflow, sorry, right? Now let's understand the algorithm of pop operation in stack. So algorithm for deletion or pop in stack. So we have a stack array in which you have to store the elements, in which some elements are being stored, right? And top is a pointer which is used for deletion, which is basically pointing to the last location where the data is being placed. So I have named the algorithm as stack underscore pop, and here we are given the stack and the top So the top is pointing to the location where you have the topmost element. But here we are not given the third parameter that was given in the insertion or push operation algorithm, because here we don't need data. Here we have to delete the data that is already available in the stack. So just be careful about this, that the parameters will be, there will be no parameter of data in case of stack pop, but there will be data available in stack push, because we have to give some data that has to be inserted into the stack, right? Now in step 1, as I have already told you, first condition will be, before deleting anything you should check whether it is empty or it is full, it is empty or not. So if it is empty, so obviously you cannot delete anything from it, so we will simply print a message that is underflow, which says that there is no data value present in the stack for deletion, so you cannot delete it. And similarly in case of insertion, we have to check the condition where your top is equal to size minus 1. In that case your stack is full, so you cannot insert anything into the stack, and that condition is called as overflow, right? So first the condition of overflow and underflow has to be checked while inserting or deleting anything from the stack, right? Now the third point is, as I have discussed earlier, so let's say if I talk about the example, your top is 3, right? So we will first delete the data which is pointing at the third location. So element available at the third location of the stack will be deleted, and after deleting that data your top will be decremented to top is equal to top minus 1. So value deleted from the stack at top position, which is not the first index here, right? And also the second case is, there can also be a possibility when there is only one element available in the stack. In that case, when you, it is pointing to 0th location, and when you delete that data, your top will be now pointing to minus 1, right? And after this we just come out of the algorithm. So this was all about the algorithm of pop operation in stack. Now let's understand the time complexity of pop or deletion operation in stack. So we know that to delete something we will be given a location, right? And that location will be the last location where the last element is being placed. So simply you are given the location, last location, so it will be stored in top pointer, that is a stack pointer, and from that location you will simply delete the element, and that's it. So this is going to take only constant amount of time, and that constant amount of time will be denoted by big O of 1. When you will understand the concept of time complexity, you will better understand why we are writing this, right? So this was all about the deletion of, or you can say pop operation in stack. If you have any query, please post your queries in the comment box. In the next lecture we will study about implementation of push and pop operation in stack. Till then, stay tuned to my channel and wait for my next video. Thank you so much.